I'm able to access all the contents. So I'm giving you the link again. Just try if you can able to see the contents, because if I just open the folder, the contents are showing up. If they're not showing up for you, I'm not sure why, because the contents are showing for from my side. Okay. I'm sorry I can't send the assignments over the email. These assignments do not belong to Edureka. These are the ones that I send or share from my side. So I think that it should be accessible from the Google Drive if other people are able to access the same. Okay. So let's get started now. Yeah, Ramakrishna, you're able to see it. Okay, great. Yeah, good evening, Kamesh. Yes, Ramakrishna, you can copy to your drive, or you can just download this folder on your local machine, whichever way it is. Okay. Yeah, good evening, Ramakrishna. So we can start our session. In our previous week, it was a very basic kind of session, because we discussed our cloud computing concepts, how to create a billing alarm, how to access our Linux and Windows instances, the concepts behind that, where we discussed the tenancies, the cloud virtual alarms, all other concepts that are important for us to understand as to how to launch our instances and what are the things involved, right? Because launching an instance is quite an easy process, but various components like key pairs, security groups, all these things are necessary for you to understand, because once you move forward, based upon the security groups, the key pairs, you'll perform some kind of troubleshooting. Okay. Today, we'll just go a step further, and over here we'll discuss Elastic IP addresses and the public IP addresses. So what's the difference between them? What's the advantage of the Elastic IP address over the public IP address? Once we discuss that, then we'll discuss the Elastic network interfaces. So let's get on. Let's discuss our Elastic IP addresses right now. Before we can just do that, I will just do one thing. I will launch two simple instances so that we can perform the lab session. I can show you that how to associate or disassociate our Elastic IP addresses. So just give me a few seconds over here. All right, so here we go. We have launched two Linux-based instances, and we'll use these two instances to perform the lab session or Elastic IP addresses. So as you can see, that right now, just in front of you, I managed to launch two different instances in the region of Northern California. And these two different instances are launched in two different availability zones. Now, one very common behavior you will see whenever you launch any instance on the AWS Management Console, that it tends to get a public IP and a public DNS. Now, over here, there are two types of IP addresses that it tends to get. First one is the private IP and the associated private DNS. Now these are used for the internal communication, right? For the internal communication, which means that you have to have some kind of IP addressing so that the instances inside a cloud can send or receive the traffic to each other. Just right to that, you have a public DNS and the public IP, which is for the public or the internet communication or the communication across the internet. Because a public IP makes your instance public, which means that it is accessible across the internet. It can send and receive the traffic across through the internet, because internet is also a kind of, you can say, one of the biggest public clouds. So these are the two set of public IPs that we get whenever we launch our instance. Now both this private IP and the public IP are binded together through a concept called NAT. NAT stands for Network Address Translation. Now this is a concept that belongs to networking domain. So the NAT binds this private IP to the public IP. Now a public IP is quite essential for us to achieve. The reason being because the public IP will make your instances publicly accessible to or across the internet, right? Let's suppose that this instance, now this is the public IP, right? Let's suppose that on this instance A, you have launched a web server, a web application. Might be it's a WordPress blog or a Drupal site, right? So you have hosted a website on this instance, and you want that the users should send the traffic towards the domain name. So what will happen is that, let's suppose that this is a user. He will send the traffic to this instance. Now what you will do is that you will not give the public IP of your instance. You will say, okay, user, type in the following domain name, let's suppose xyz.com. And this domain name will point towards this public IP. It will resolve to this public IP, which means that if your web server or the web application hosted on the instance needs to be reachable, which means that at the back end you will bind your domain name with the public IP, which means that this public IP should be static at all the times because it is binded to the domain. Whenever the user types in www.xyz.com, it gets resolved to the public IP, which belongs to the instance upon which your web application or the web service is being hosted, right? So let's do one thing. Let's copy this public IP somewhere so that we can use that for our future reference. So I'm just opening up one of my notepad files, and I paste this public IP. So I just type it as public IP, right? Public IP of instance A, so that we can differentiate that which instance this public IP belongs to. So this is the public IP of our instance A, 54.183.186.143. Now let's do one thing. Let's go ahead and stop this instance, and let's see what exactly happens. We're stopping this instance, and we will see the behavior that what happens exactly to the public IP. So this we're watching right now. Let me just hit refresh and see that If something happens, okay, it's still the same. Nothing has changed to the public IP so far. Okay, now still stopping. Okay. Now, as you can see on your screen right now, as I stop the instance, the public IP is gone. It's no more there. Now, let's do one thing. Let's restart the instance. I go to Actions again, Instance State, and start the instance. Okay, so as soon as I start the instance, I get the public IP. However, I need to verify, is this the same public IP that I got before? Just copy this one. So the answer is no. The previous public IP was 54.183.186.143, and the new public IP is 54.153.99.187. This is your new public IP of instance A. So before we restart it or stop the instance, this was the public IP that we were getting, and now this is the one that we're getting right now. Let me just copy and paste that on a Word document so that it is more visible. Okay. Hang on one second, please. All right. So let me just increase the font size. All right. So these are the two different public IPs, and this is the new one. This is the new public IP of the instance I. So we can conclude one thing over here, that whenever you restart the instance, it is subjected to change its public IP. Now, in our previous example, what we discussed one thing, that if this is a user, he will send his request to the instance, and you will bind the domain name for the website towards the public IP, and this public IP will point towards the instance. Now there's a big problem. As soon as you restart the instance, it tends to lose its previous public IP, which means this is gone. It's no more there. Now, whenever the user types in xyz.com, it will still point towards the old public IP without even knowing that this is the new one that is already being there associated to the instance. Consequently, the user will get the following thing: the page cannot be displayed, or he will not be able to access your website. Which means that now you have to go back and manually you have to associate this new Elastic IP, the public IP, to this domain name. So that xyz.com, whenever a user types in xyz.com, it points towards this new domain name, not this one, which no longer exists. Okay. So public IP are subjected to change. So whenever you restart the instance and you have a web application hosted, you are bound to change your DNS entries, because if you restart the instance, the public IPs are subjected to change. Henceforth, whenever you restart the instance, every time you have to modify your DNS entries, your domain name entries, so that your domain names or the DNS entries point towards the new public IPs. Now this is quite tedious, involves risk, and not that much feasible, because If you restart the instance by yourself, you know that you have to make the DNS changes, or you have to make the changes in the DNS entries. But sometimes this instance may restart automatically. In that case, you'll not be able to know that, okay, something has gone wrong, the instance got restarted, and it's got a new public IP. So if someone complains to you that, okay, I'm not able to access your website, then you get to know, okay, then you open your management console and say, okay, this is the new public IP, I have to change the DNS entries. So, which means public IPs are not that much reliable. They are dynamic in nature, and they are subjected to change each time you restart the instance. Now, the question may be asked, why so? Why the public IP changes whenever I restart the instance? Because public IP are binded to instances. Public IPs are binded to instances. So whenever you stop the instance, the Amazon Web Services will assume that, okay, you're not using the instance, why to waste a public IP? This public IP, whenever you stop the instance, so whenever you tend to stop the instance, this public IP gets back to the pool of the public IP addresses that is being managed by Amazon Web Services at the back end. Because what happens is, at the back end, the AWS, they maintain a pool of public IPs. So whenever you stop the instance, this public IP goes back to the pool. Because once you stop the instance, it is quite obvious that instance is no longer used from Amazon Web Services perspective, and it pulls back its public IP because the public IP is binded to your instance. So that's the reason. Okay, so now the solution for this, guys, I'll just come to question later on. The solution for this problem is that we have a thing called Elastic IPs. Elastic IPs are public IPs itself. However, their nature and their behavior is completely different. On the left side, if you see over here, I have this section under the network and security called Elastic IPs. This dashboard is blank because I don't have any Elastic IPs allocated, so I can just click on allocate new address. It says, are you sure you want to allocate a new IP address? I would say yes, allocate. And Amazon Web Services gives me this new Elastic IP. Now this new Elastic IP that I just got, it is not binded to an instance. If you see over here, the instance section is blank. So once Amazon Web Services allocate a new Elastic IP to me, I can very well assign it to any of the instances running in the same region where this Elastic IP is being generated. Now over here, if I just go back, let me do one thing. So if I just go to the instances, this is the new public IP that I just got after I restarted the instance, right? If I assign it this Elastic IP over there, this one, this instance will lose its new public IP. So as soon as I assign an Elastic IP to it, it will tend to lose its public IP. So let's click on. I go to Elastic IPs, select the Elastic IP over here, I go to Actions, and click on Associate the address. So I have to select the instance A, and I click on Associate. And now, if I just go back to the instance, you will see the previous public IP is being released, and the new Elastic IP is equivalent to the public IP. So let me just copy and paste Elastic IP over here. So if I just open my WordPress file, so now my new public IP is equal to the Elastic IP, which is this one. Okay. So hang on 1 second. So if you see over here, right. So this previous public IP is being released. It went back to the pool of Amazon Web Services, and it's got the new Elastic IP that is equal to its public IP. Now let's do one thing. Let's stop this instance and see what happens. So this instance is getting stopped. So we have to see whether it tends to lose this public IP or the Elastic IP or not. Let's wait. Venkat is saying he lost the audio for a few minutes. Guys, are you facing the same problem again? Are you losing the audio? No? Okay, Kamesh is saying no. Azar is saying yes sometimes. Guys, I'm not sure because half of the people are saying no and some are saying yes. Okay, Venkat is saying it was issue with your machine. Alright. Okay. Guys, I'm not sure. I got it checked at the back and there's no problem. So if 1 or 2 people are facing the problem, you have to just see whether you're getting a proper internet connection. Okay. And also, it is always advisable before joining the session, you just delete all the cookies from your browser or all the junk from the browser so that it never interrupts your session. Okay. So guys, as you can see right now, this instance in front of you, it is stopped and the public IP is still over there. I start this instance again and you will see the public IP or the Elastic IP will still remain over there, which means the Elastic IPs never ever change even if I restart the instance, which means they are static in nature as compared to the public IPs which are dynamic in nature. Elastic IPs are static in nature, whereas public IPs are dynamic in nature. The purpose is same, to make your instance publicly accessible or reachable across the internet. However, the way they work is completely different. Public IPs tend to lose whenever you restart the instance, whereas Elastic IPs never get released even if you restart your instance. Now, the question may be asked, why it is so? Because Elastic IPs are intacted to your account, not to your instances. Because if I go to the left side, you can see these Elastic IPs are associated to my account. So even if I restart the instance or stop the instance, the Elastic IP, let me do one thing. I go to the instance. Okay, let me just go back to Elastic IPs. I go to Actions and disassociate this Elastic IP from the instance. As soon as I do that, the instance will get the new public IP. You can see over here. What I want to show, or what I want to prove over here is that the Elastic IP is intacted to your account, not your instance. It is independent from the life of your instance. So even if you restart the instance, terminate the instance, whatever you do with the instance, the Elastic IP still remains over there, because at the back end, Elastic IPs are associated or bonded to your AWS account, not the instance. If you don't assign to the instance, it is still there in your account. I go to actions again and associate to the same instance. You can see over here. And now the instance has got back the same Elastic IP. Whereas the public IPs are associated to your instance, not to the account. So whenever you stop the instance, it gets released. So that's the difference. Okay. There is a second advantage of that. I'll just let you know. Now let's take the questions. Venkat is saying, in my case, public DNS is not changing. Venkat, in the ideal situation, it should change. Whenever your public IPs change, the public DNS also changes. Yeah, so Venkat, if the public IPs change, the public DNS will also change. In that case, you have to change the DNS entries. Now don't mix the public DNS over here with the DNS entries over. I'm not referring to this DNS. So hang on 1 second, please. Okay, so when Venkat, I'm not referring to this public DNS, not this one. This is a separate thing. The DNS entries means that the DNS, the domain name that you change, use like Facebook.com, Google.com, XYZ.com, your company's website, public domain name. That's I'm referring to. So if whenever your public IPs change, you have to point your domain name towards the new public IPs. Okay. Kamish is saying, do we have any range of IP addresses? Kamish, the thing is that what kind of IP addresses you get to the public IPs or the Elastic IP is not in our hands. Okay. But if you want to get access to the range of IP addresses, then you have to see the AWS documentation. Kamish is saying, do we have any range of public IP address pool from this? Kamish, you have to see the AWS documentation. They have a website where they have displayed what's the range of the public IPs they have for few regions. Venkat, you're saying how I'm able to access my Drupal site even though IP changed. Venkat, that you have to investigate by yourself. It is never ever possible that if you have changed the IP address, using the same IP, if the IP is not associated to your web server, how can you access it? It is not possible at all. So you have to, I'm not able to see your Drupal site on my screen right now. So you have to investigate by yourself. Why? So if it has changed its public IP, it is quite obvious that if your DNS entries or the domain name, it is pointed towards the old public IP, it can never be accessible. And again, I'm saying, don't mix the public DNS with the domain name that I'm referring to. Venkat, it's not the public DNS. I guess you're still getting confused with this one. Don't get confused with this one. I'm not referring to this one. I'm pointing toward this one. The domain name that I'm referring to is the one that we use for our company's website, like Facebook.com, Google.com, Accenture.com. the real domain names. I'm not referring to this one. Okay. No, Ramakrishnan, your question is, can I use my own IP? No, it's not possible in the Amazon Web Services. You can use it in your own infrastructure, in your own network, but not on the Amazon Web Services. No, Ramakrishnan, it's not possible because Amazon Web Services, they have their own public IP address ranges that they serve to the customers or give to the customers. You don't have any choice to choose your own. Not possible. Okay. As I was saying, is that how to assign my own IP provider network team? Other the thing is that your network team take care of your company's network. Amazon Web Services network is different from your company's network. Your network team can have full control of the IP addresses that they can implement in their own company's network, not the Amazon Web Services network. So over here we have to keep one thing in mind, that Amazon Web Services is a separate network that does not belong to our corporate. Network team can help you to choose the private IP addresses ranges for the communication between the private subnet and your corporate network. There they can help you. Okay. All right, guys. Kuram, your question is, can Elastic IP can be assigned to any state of the instance? You mean to say whether it's stopped or started? Yes, Kuram. If it can be in any state, whether it's stopped or running, the Elastic IP can be very well assigned to it. Whether the instance is stopped or it is running, any state, right? All right, guys. So let's do one thing. Let's discuss our second advantage over of the Elastic IPs over the public IPs. Okay, as I was saying, after assigning the Elastic IP, will I be able to download this software from a machine on AWS? Yes, of course, Azure. Elastic IPs has nothing to do with your applications running. Elastic IPs define the reachability. So even if you assign the Elastic IP, you can download the software from your machine to the AWS. You can very well do all the things that you can do before. Ramakrishnan, your question is, will this not become a problem during clustering my premises environment? No, Ramakrishnan, it will not be a problem. Once we discuss a VPC, then we'll discuss that. Because whenever we do the clustering, we use the private IP addresses to the clustering. We never ever depend upon the public IP addresses. So once we discuss a VPC or the clustering, we'll discuss that. Okay. So over here, our main emphasis is reachability, not the clustering. So how to overcome the situations in clustering, we'll discuss in the VPC. All right. Okay. Now, one thing we have to keep one thing in mind: the public IPs is not in our control, whereas Elastic IPs are. Because I can assign the Elastic IPs, I can disassociate, I can release it. Elastic IPs are completely under my control. Right now, I go to Elastic IPs. I can just go to actions, disassociate from my instance. If I want to get rid of this Elastic IP, I can just go to actions and release it. Elastic IPs are completely under my control, whereas public IPs are completely in the control of Amazon Web Services. I can allocate a new Elastic IP, and this is a new Elastic IP I just got. Now, I just go to the actions and associate to the same instance again. So Elastic IPs are it's completely at my disposal how I can use it. Now, Let's discuss one scenario. Let's suppose that you have this Amazon Web Services Cloud, right? And you have or what you have done is that this is your first subnet. This subnet A, it is associated to availability zone A. Right to that, you have a second subnet, subnet B, that is associated to your availability zone B. Right. Now, what you have done is that you have launched one instance. This instance is your primary. So I'm just denoting as P server. In a second availability zone, you have a backup. So I'm just denoting as B server. So you have designed you have structured your architecture in such a way that this primary server will handle all the traffic, whereas this backup server, it is just a standby server which you will use in case if the primary server fails. Right? So what is happening in a very ideal situation, that this is a user, right? He opens his computer and types in the domain xyz.com. This xyz.com points or results to the Elastic IP. So I'm just writing down it as EIP, Elastic IP of this primary server, right? So user opens his computer, types in xyz.com, it gets resolved to the Elastic IP that belongs to this primary web server. Now something went wrong, and this server went down. It goes down. Now you have this standby server. What you can do is that you can very well take this Elastic IP and bind it to the standby server. Consequently, this domain or this domain traffic will be now rerouted to your standby server. So whenever a user types in xyz.com, this will result to the same Elastic IP, but now this Elastic IP is a part of your B or the backup server now. So this Elastic IP, this one, I can very well take it from the private server which has now failed and associate it to this backup server which is now active. Which means that Elastic IP helps me to route or reroute the traffic towards the healthy instances in case of any kind of failure. This kind of capability, this kind of advantage, and I can never ever get with the public IPs. The reason being, the public IPs are not in my hands. It's not in my control. So let's do one thing. What I will do is, let's suppose that this instance A is my primary. Server, and this instance B is my backup server, right? So this primary server has the Elastic IP associated. What I will do is that I will disassociate this Elastic IP from the primary server and associate it to the backup one. Let's do one thing. So as a first step, I will take out or disassociate this Elastic IP from the primary server. I go to the Elastic IPs, go to Actions, and click on Disassociate. It says, are you sure that you wish to disassociate this Elastic IP? I would say yes. Now, once I go back to the instance dashboard, this backup server has got a new public IP, which is quite natural, because as soon as you disassociate the Elastic IP, the Amazon Web Services automatically gives a new public IP to any of the servers. Now, this Elastic IP that I disassociated, it is sitting idle because the instance box is blank. As soon as I associate this Elastic IP to my instance B, or the private server, its previous public IP would get released and it will get a new Elastic IP now. So I go to Elastic IPs, go to Actions, and associate it to the instance B, or the backup server. Previously, this Elastic IP was a part of the primary server. Now I'm associating it to the backup server. So now this backup server has the same Elastic IP, which means consequently I can reroute the traffic. How? Because the traffic is routed based upon the IP addresses upon the MAC addresses. The traffic never knows which machine it has to route the traffic to. The traffic understands the public IP or the MAC addresses. So if you reassociate the Elastic IPs, you're fooling the traffic somehow, and you're diverting the traffic to some other healthy instances running in the same region. It's a quick, I would say it's a quick fix, or you can say it's a manual failover process. This thing you can never ever achieve with the public IPs because you don't have any option to disassociate or reassociate the public IPs. But this capability, you get that with the Elastic IPs. Okay. Azhar, your question is Elastic IP chargeable by Amazon Web Services? Azhar, let's come to that. Venkat, your question is, why can't I release Elastic IPs when my instance is stopped? Of course, Venkat, you can do that. I've shown you how to release your Elastic IPs. You have to, how you can release the Elastic IPs? Let me show you again. You go to your Elastic IPs. You need to disassociate first. And then you can just go ahead and release it. All right? So that's the procedure. Kiram, your question is perhaps there are few people like me who don't know what is subnet, why need it. Kiram, it's not required at this point of time. Once we discuss the VPC, then we'll discuss that. So Vijit, your question is, so there's an option to choose Elastic IP also? So Vijit, you don't have any choice that which range of Elastic IP you can go for. If I'm saying it's completely under your control, which means you can perform the disassociation, reassociation, that you can do. Venkat is saying it is possible to do auto failover. Yes, Venkat. We'll discuss the automated processes later on. Kamesh, you have the same question. Do we have the manual or automatic processes available? Kamesh, we have both the manual and the automated processes available. Right now I'm discussing the manual one. Okay. So allocate a new address again. And it's associated to one of the instances. Okay, now coming to the prices. You have to keep one thing in mind, and this is quite important from the examination perspective. You get 5 Elastic IPs 5 EIPs per region, absolutely free. Also, this is the limit. You can't exceed that. Whether it's a free-tier account or a business account, you can never have more than 5 Elastic IPs per region. Yes, you can get more, but you have to open a case with the Amazon Web Services, and they can give you some more Elastic IPs for a small charge, right? Now I'm saying you get 5 Elastic IPs per region per account free, but there's a big star, big terms and condition applied. Even though you get 5 Elastic IPs per region free, Amazon Web Services can charge you for that. How and why? See, the thing is, Amazon Web Services says that we give you 5 Elastic IPs per region free. However, you have to commit that you don't waste that. Right now, this Elastic IP is assigned to an instance which is running. If I go to actions and disassociate and I keep my Elastic IP idle, the Amazon Web Services will start charging me for this Elastic IP. So AWS says that don't keep the Elastic IPs idle. If you do that, we're going to charge you. Now you might be wondering why this kind of weird model, because there's already a shortage of public IP addresses in the networking domain. So to discourage the wastage of the Elastic IPs, the AWS has come that, okay, you get 5 Elastic IPs per region free, but if you waste it around and don't assign it to any of the instance and just keep it sitting idle, we're going to charge you. Also, this Elastic IP should be assigned to a running instance. Running. If it's assigned to stopped instance, still they will charge you. So let's suppose I go back to my instances. I stop this instance. I go back to my Elastic IPs and assign this or associate this Elastic IP to my stopped instance. Amazon Web Services will charge me for that. Okay. So you get 5 Elastic IPs per region for free. However, the condition is that the Elastic IP should be assigned to a running instance and it should not be sitting idle. Right now, this Elastic IP is assigned to a stopped instance, you can see. And the Amazon Web Services will start charging me for that. So, first condition, never ever keep your Elastic IP sitting idle, which is not assigned to any of the instances. You have to assign the Elastic IP to any of the instances, and also that instance should be up and running. If it's sitting idle or it is assigned to a stopped instance, in that very case, the Amazon Web Services are going to charge you. Now, just in case if you are thinking that the Elastic IPs are getting wasted and you're not using that, go ahead, disassociate, and release it. Just release it so that the Amazon Web Services will not charge you. Okay, so this is the billing model of your Elastic IPs. So Venkat, your question is, what if the instance is shut down but the Elastic IP is still associated? So I hope I answered your question. They will charge you. Raj is saying when they'll start charging. Raj, as soon as you perform the disassociation, based upon the overage charges, they will start charging you. So they will not charge you for the entire 1 hour, but the portion of 1 hour. So if it's just few seconds, so I don't think they're going to charge you just a few cents. But if it's more than 1 hour, then they will charge you. Okay. So Raj, as soon as you perform this kind of disassociation and keeping idle, your bill will start. But I guess after 1 hour, they will start charging you. Okay. So this is the billing model of the Elastic IPs. Now, I haven't used this slide before, so I'll just summarize this entire session of Elastic IPs. Well, what's the public IP using the slide? Hang on one second, please. So public IP versus Elastic IP. Public IP addresses is reachable from the internet, from the pool of the Elastic IP addresses. This is assigned to your instance and is not associated with your AWS account. This thing you have to keep in mind. This thing you have to keep in mind. The public IP is not associated to your account. Through NAT or the network address translation, your public IP is mapped to the primary private IP address. You use a public IP for communication between your instances and for the internet communication. Every instance gets a public IP, also it gets an external DNS host name. Public IP cannot be manually associated or disassociated from your instance. Reason being, it's not in your control. Public IP is not in your control, therefore, it cannot be manually associated or disassociated. This thing you have to keep in mind. After the release of public IP, you cannot reuse the public IP once it is disassociated from the instance. The public IP gets back to the address pool. When you restart an instance, it gets a new public IP. Okay, so that's about the public IPs. Elastic IP addresses. Your Elastic IP addresses is a public IP that you may allocate to your account. So account, this is for your account, not for the instance. An Elastic IP or EIP is allocated to your account unless you release it. It takes several minutes to remap an EIP. It's not required to have an Elastic IP in all your instances. So this is an optional thing for you to go for. You are limited to 5 Elastic IPs per region, but if you wish to have more, you may apply and the Amazon Web Services will look over your case. So you can get more Elastic IPs. You have to open a special case with the Amazon Web Services. Okay. So this completes our Elastic IPs versus the public IPs. Kuram, your question is there a limit to purchase the number of Elastic IP for my organization? No, there's no limitation, because you have to give certain amount to the Amazon Web Services. So they will welcome you if you purchase more Elastic IPs. Okay, so there's no limitation. But I've heard this that they give you a package of 20 Elastic IPs. So I think for each package you can get 20 Elastic IPs. So you can get more packages depending upon what's your requirement. Okay. So guys, this completes this topic. Any questions, any doubts? No? Okay. All right. So let's just discuss our next topic, that's called the Elastic Network Interfaces. All right. Now, whenever you go to an instance, you will see one thing. You just scroll down in the description, and here you can see the network interfaces ETH0. This ETH0 is is your default Elastic network interface. Now we have the LAN cards, network interface cards embedded in our laptops, desktops, servers, sorry, that help these machines to communicate with other machines over the network. Now, we can very well use this network interface to perform the failover and also to assign multiple IPs to an instance. If someone asks you how to assign multiple public and private IPs to the same instance, what's the solution? It's the network interfaces that can help you to achieve that thing. Right? Now, if I go to my network interface ETH0, I click on this one. This shows me the interface ID. The attachment state is attached, the time and date. Okay, so these are the different details I can see for this default network interface. So I click on this ENI ID, and this takes me to the Elastic Network Interface dashboard on the left side. You can see under Network and Security over here, where you can see my cursor. Now, once I select this default Elastic Network Interfaces, 3 different attributes or properties you have to focus upon right now. The first one is the MAC address, this one. Each and every default or any other network interface will get a unique MAC address. Also, apart from the MAC address, this network interface, it has a private IP, right? And if you scroll down, it's actually the public IP. Give me 1 second over here. So it also gets the public IP. I will show you where you can see that. So you have this MAC address, and also you can see that it has the private IP. I'm not sure for some reasons it's not showing the. I think it's stopped right now. Give me 1 second. Okay, it is stopped. That's why. So let me just go to the backup server. Hang on 1 second. Let's start this again. Okay, so I just choose a different server because the previous one was stopped. I go to its network interfaces, go to network interface ID, and you will see that this will have a different MAC address, the public IP, and the private IP. So what happens is that whenever you assign the public IPs or the private IPs at the back end, those are assigned to the network interfaces. So you can imagine that this is your instance, and this is your network interface binded to it. So these 3 attributes are the properties: MAC address, public IP, and the private IP are associated to this ENI, or Elastic Network Interface, which then reflect in your instance properties. Right? Now, let's do one thing. I've chosen this network interface. I go to Actions at the top, and I go to Manage Private IP Addresses. Right? You can see over here, it shows me the private IP and the public IP of this instance to which it is binded. Now I get the more option to assign more IPs over here. I can either just leave it to our auto assign and click on yes update, or I can type any random private IP from the subnet range. So let's name it as 60, right? 60 and click on yes update. This default network interface number of private IP does this exceed the limit. I think we can assign 2 private IP addresses. Okay, I think it got. Hang on 1 second, please. Okay, I'm not sure why it showed the error message, but you can see over here. If you just keep a closer look over here, these are the 2 IPs that I got. This one was before I performed the disassociation of the new private IP, and this is the new one, .60. Right? Which means whenever I associate more private IPs to an instance or to the network interface of an instance, that gets binded towards my instance. So this is the previous private IP and this is the new one that I just got binded to the network interface. Now I just go back, I go to actions again, manage private IP addresses, and you can see that this is the new private IP which was showing up for my instance as well. Now I can associate a new public IP for this private IP. Now, as I said before, public IPs are not in my control. So what I can do, I can assign an Elastic IP to this private IP. So I can go about doing that. I just copy the network interface ID. I go to Elastic IPs, allocate a new one, and this time I go to actions and associate this address not to an instance but to an Elastic network interface. And then I choose the private IP. This is the secondary one that I just got associated. And I click on associate. So now let's go back to the actions. I'm sorry, I just go back to the network interface. I go to actions, manage private IP addresses, and you can see I got the new public IP associated to the new private IP. And now if I just go back to the instance, you will see this instance has got the 2 public IPs now and 2 private IPs. Which means I can use the concept of Elastic network interface to assign the multiple set of private and public IPs to my instances. And the question may be asked, why on the earth we need multiple IPs? Because to make your instance more reachable. For example, these are the 2 public IPs assigned to instance. If this is not reachable, then this can become active. So you can perform some kind of load balance or active or active passive kind of thing, so that if one of the public IPs is not reachable, then the user can reach your website using this secondary public IP. All right. So this is the concept of Elastic network interface that can help you to assign multiple private and public IPs to the same instance to increase its chances of reachability. Any questions so far? Subhajit is saying private IP subnetting can be possible. Yes, Subhajit, private IP subnetting is possible. We'll discuss that in the VPC. Right? So guys, this concept is clear. Assigning multiple private and public IPs using the concept of elastic network interface. All right, cool. Now, let's do one thing. I just go back. Now, apart from that, you can have multiple network interfaces assigned to the same instance. Right now, to the server or to this instance, I have this default network interface assigned. I can assign a secondary network interface. So what I can do is I go to network interfaces. This is my network interface dashboard. I go to create network interface. I just name it as secondary ENI. Now, one thing you have to keep in mind that you have to select or choose the same subnet while creating an ENI, because this ENI and the instance should be in the same subnet. So you have to choose the appropriate subnet. Okay. And also you assign a security group to the interface. Click on create. So over here, you can see over here it is showing available, which means that it is free. I go to attach on the top and select the instance. So one thing you have to keep in mind that whenever you want to bind any of the network interfaces to the instance, both these two components should be in the same availability zone. So I click on attach. So if I just go back to the instance description, I can see over here, if you see that it has two interfaces. The top one is the default one, and this ETH one is the secondary one. So you can have multiple network interfaces assigned to the same instance. The question may be asked, why on the earth we have to assign multiple network interfaces? I'll just come to that point. All right. Apart from that, the concept of network interface helps you to perform the failover within the same availability zone. Now, this secondary network interface ETH1 that I've assigned to this backup server, let me do one thing. Okay, so what I can do is I can disassociate. Now, this ETH1, if I just go back. Okay, let me just create a drawing so that I can make it more understandable. So let's suppose that this is your Amazon Web Services cloud, right? And okay, let me just create again. So this is your cloud, and you have these two different subnets. Now, right now you can assume a subnet is a block of IP addresses. That's it. We'll go further once we discuss the VPC. A subnet is a block of IP address ranges that represent your availability zone. Okay. Now, you have a subnet A in the availability zone A. You have a second subnet B in the same availability zone A, which means you have two different subnets in the same availability zone. Right? Now, you have this instance running. This instance is your primary server. I'm just denoting as P. you have another server that is a backup server or a standby server. So it's a same kind of situation. The primary server over here, it will handle all the traffic. The backup server, it is just a standby server, because if the primary one is down, the backup server will come into action. Now, with this primary server, you have this Elastic Network Interface assigned, ENI. I'll represent as ETH0. Now this ETH0 will contain or will have different attributes associated. MAC address, public IP address, and the private IP address. These three properties are common for all the network interfaces. Now what happens is that, let's suppose that this primary server goes down. What you will do is you will perform a quick switchover. You will take this network interface ETH1 and bind it to your instance bay, which means all these three properties, MAC address, public IP address, and the private IP address, gets carried over and gets associated to your instance bay, which means this will result in the rerouting of the traffic in the same availability zone. Why? Because these three properties are being carried over and associated to your instance bay. So what I'll do is, let me do one thing. I create a new interface. Let me do one thing. Let me detach this one. Okay, so I need to launch another instance real quick. Hang on one second, please. Okay, I just name it as right. So let me launch another instance in the same availability zone. Guys, just give me 1 second and just launch the instance real quick. Right. So guys, what we'll do right now is that this instance B is getting launched right now. Okay. I'll perform some operations on the instance A. So what I will do is I'll attach this secondary network interface to my instance A running in availability zone US West 1C. Right. I will just go back to the I just see the properties of this network interface. This is the MAC address of this network interface, the private IP, and let me do one thing. Let me assign a public IP to it. I copy this one, go to Elastic IPs, and I assign it to this network interface right now. So now this network interface has three properties: MAC address, private IP, and the public IP. Right? And these three things would be associated to this instance. I click on this one. You will see these IPs are associated to this instance through the Elastic Network Interface. What I will do is I'll disassociate this network ETH1 so that all these properties are carried over. I go to ETH1, I click on detach. Once it is detached, I will attach it to my another instance in the same availability zone. So let's wait for a few seconds. Okay, you can see it is showing available. Now I click on attach and choose a second instance B in the same availability zone. And now you can see that this interface has been moved over to a second instance and all these properties are being carried over. You can see. Which means that whenever I disassociate the network interface from one instance and associate to another instance in the same availability zone, the MAC address, private IP, and the public IPs get carried over, and they get binded to another instance. Which means that now this instance will receive the same traffic that the previous instance was receiving. All right. Any questions so far? Yes, Raj, we'll just take a break. Any questions, any doubts? So I guess this concept is clear. So network interfaces can help you to perform the rerouting of the traffic, and also it can help you to assign multiple public and private IP addresses to the same instance. All right. Kamesh is saying, so just replace the old network interface with a new one? No, Kamesh, I didn't replace the network interface. I'm performing the assigning of the new one. If I go back to my AWS Training console, you can see that this ETH1 is a new one, ETH0 is a default one. Now I cannot perform this association or disassociation with the default one. If I just go to the ETH0 right now, you can see on the top where you can see my cursor, this attach or detach option is grayed out. It's grayed out. I can never ever perform this operation with the default network interface, which is represented as ETH0. But I can perform this operation of attaching and detaching using the secondary network interfaces. All right. So I'm not replacing anything over here. It is just that I'm just creating a new one and performing the disassociating between the instances. So it will never replace the old one, but it will add more network interfaces to the instance. So it will be ETH0, ETH1, ETH2, ETH3, depending upon how many network interfaces that instance can support. So Kamesh, your question is, so here I can use any public IP address for public API? Yeah, Kamesh, depending upon, yeah, you can use any of the public IP addresses listed over there. So if you have 3 or 4 different public IPs associated to the instance, you can use any one of the one to communicate with your APIs. All right. So that's it, guys. I have to just briefly summarize this thing through a slide. Let's do one thing. Let's take a 10-minute break. You guys can refresh yourself. Today I will just take 2 breaks of 10 minutes. So right now you can just take a break for 10 minutes. You can refresh yourself. Once you come back, we'll just briefly summarize the concept of network interfaces. Then we'll discuss the CLI, the command line interface. All right. So it's a break for 10 minutes. All right. Thank you. Welcome back. I guess all people are back now. So we can summarize the concept of elastic network interfaces. So an elastic network interface is a virtual network interface that is attached to your EC2 instance. And each instance in a VPC has a default network interface. You can attach or detach your instance at any point of time from your instance. An ENI or elastic network interface detached from an instance can be attached to another one in the same availability zone. An ENI consists of, private IP address, additional private IP addresses, public IP address associated with each private IP address, MAC address, security groups, and the source and the destination check flag. So these are the three properties that gets associated with any one of your network interfaces. Now what happens whenever you detach the ENI and attach it to another instance? All these three attributes or the properties get carried over and they get themselves attached to any other instance to which your instance this elastic network interface has been attached, which results in rerouting of your traffic. Now we discussed one thing, that we can attach multiple network interfaces to the same instance. Now how this benefits you? This helps you to create something called management network. Now if you can draw your attention towards this diagram, you can see one thing over here. There's a web server running in the middle. On the right side it has a default network interface ETH0, which is handling the management traffic. On the left side we have ETH1, that's a secondary network interface, which is handling your public traffic. Management traffic means that which is between your data center and your VPC or the cloud, and the public traffic that is coming through the internet. So a single web server can handle two different types of traffic, which helps you to save your cost. If you design it properly, then you can bring down the number of instances to half, or depending upon how many interfaces you can attach to a web server. So a single web server can handle different kinds of traffic. So this helps you to bring down the number of instances required, and the same web server can handle different types of traffic for each subnet. What are the best practices for configuring network interfaces? First thing first, the default network interface ETH0 cannot be detached from an instance. This thing you have to keep in mind. An ENI has to be the same AZ or the availability zone where the instance resides, so that it can be attached to that instance. There are three types of attaching methods. Hot attach. Hot attach means that you are attaching the network interface to the instance when it is running. Warm attach. Warm attach means that you're attaching your network interface to the instance when it is stopped. Cold attach. Cold attach means that you are attaching the network interface to the instance during the creation or the launching process. So these are the three types of attaching methods. All right. So this completes the summarization of the network interfaces. Any questions in and out so far before I can just move forward? I'm just pausing a few seconds and waiting for your response. I guess no questions right now. Okay. So Kamesh, I just paused a few seconds. That's why you were unable to hear. Okay. So I think there are no questions as of now. I can just move further. Ramakrishnan, warm means that you are associating the network interface to the instance when it is stopped. Okay, that's the warm-up kind of attaching method. All right. Okay, I'll just go to it again. So hot attach means that you are attaching the network interface to the instance when the instance is running. Warm attach means that when the instance is stopped. Cold attach means that the network interface, that's a default one, ETH0, gets automatically associated to the instance during its creation or launching process. So whenever you launch an instance, the default network interface gets associated automatically. So that's called the cold attach. Okay. Right. So this completes our 2 topics for today. Elastic IPs and the elastic network interfaces. Now let's discuss our next topic, that's the CLI, command line interface. I'll just brief you about it, not go in details because that's not required at this point of time, but you should be familiar with the CLI. Now this is the GUI, graphic user interface, or the AWS management console that we're using so far to spin up our instances, perform different operations. Now we'll use a command line to perform the same kind of operations. Now, why on the earth you will use a command line if you have I would say, this beautiful interface, but it's quite easy to use? The reason being because there are some kind of operations. I mean, so to say that, for example, if you have to perform some kind of automation or run some bootstrap scripts, you can never run that on the Amazon Web Services. There are some restrictions. Also, in some of the client environments, you may not have access to this entire console. So your customer will give you access to the CLI so that you can perform some operations. So in few cases, you may use the CLI or the command line interface. So I'll just make you familiar with that platform. Now, first thing first, you have to install the CLI tool and necessary softwares in your computer. Let me show you. If you just go to the Google, hang on one second, if you just go to Google and just type the following. So now, AWS CLI install. The first result that you will get that contains the entire documentation how to install the CLI on your local machine, laptop, or the desktop that you're working right now. I'm just copying and pasting this link for you on the chat window so that you can just go through it. Right. Now, depending upon whether you're running Windows, Linux, Unix, or OS X, you can install the packages of the CLI. For example, if you are running Windows on your machine, click on that. And depending upon whether it's a 32-bit architecture or a 64-bit, you have to install the CLI tool on your Windows machine. Right? I guess most of you guys are using Windows. Right now I'm using Mac OS X. For the Windows, once you install the CLI tool from this page, the next thing that you have to install is the latest version of Python. So it goes as python.org. This is the website you have to go to. Once you go to this website, just go to downloads and download the latest version of Python 3.5.2. For the Mac OS X, it's not required, but for the Windows, it's required. So I'm just copying and pasting this link for you on the chat window so that you can download the latest version of Python. Right? So these are the two necessary softwares for you to access the CLI tool itself, and the latest version of Python. Once you install these packages, you're good to go. Now, after the installation of the packages, what do you need to do? You have to use your command prompt on your Windows CMD. You just go to the start window and type in CMD or command prompt. Open the command prompt. On my Mac, I will be using the terminal. So for the guys who are using Windows, you will use a CMD or the command prompt. On the Mac, I'm use the terminal to access my CLI. Now I'm not sure whether I installed these packages or not. Give me 1 second. Okay, so on this PC, it's not installed. I haven't installed right now because this is my new PC. Hang on 1 second, please. So I'm just installing the link, this thing in front of you right now on my Mac. Hang on 1 second, please. Okay. Okay, so for the Linux and OS X, I'm just showing the steps right now. So I just installed this AWS CLI bundle installer. Or let me just give you 1 second. I think we have to just run the curl command. Hang on 1 second, please. So it is installing the package on my Mac terminal. Let me just increase the font size. So right now it is downloading the necessary packages to install the CLI tool on my Mac machine. That's right. Okay. So let me just run another script or unzip this folder. Okay. And let's run this command. Okay, I guess it's done now. Let's check. Okay, so you can see on my Mac terminal, it just took me 1 minute to install all these things. Okay, for the Linux or the Mac OS X, you have to install these packages using the commands. Now, how to, even it's a Windows or the Mac or the Linux, it doesn't matter. Once you install the packages, this is the following command that you have to run. AWS, let me do one thing. Just minimize this window. Okay, this is the command that you have to run. AWS space -- version. So this shows you the version of the CLI and the Python installed in your machine. So for the Windows guy, once installed the latest version of Python and the CLI, open the command prompt, run this command, and once you get the output, which means that the installation has been successful. Right? I guess it's clear till the installation part. Any question, any doubts before I can move further? No questions? I think the installation process is clear. So you have to use 3.5.2. You can go for that. Okay. No, Kamesh, this will not work on Windows PowerShell. You see, Windows PowerShell is a different thing. You can also use a Windows PowerShell. But right now, you're using the CLI tool, not this PowerShell. You can also use a PowerShell as well. But that will have some different commands. Okay. So this is about the installation. Now the time has come for the configuration. Once you open the terminal or the command prompt and you have verified that it's been installed, run the following command: AWS space configure. Now, this will ask you for the access key ID. What's that? Access key ID or the secret access key ID you will use to get access to the AWS resources using some third-party API tool or software. Now, this terminal that you're looking at right now, or the command prompt that you use on the Windows, these are not the products of Amazon Web Services, right? These are the third-party applications. In order to authenticate these applications, whether it's a command prompt or a terminal, you have to use something called access key ID or the secret access key ID. Let me show you how you can get that. Go to the AWS Management Console. Go to Identity and Access Management under Security and Identity. Just click over there. Once you click to Identity and Access Management, just go to Delete your root access keys. Click on Manage Security Credentials and click on Access Keys and the Secret Access Keys. Now I already have the one created, so I just delete one of them. You'll get a window to create a new access key. Click on Create New Access Key. And you click on Show. And this will give you the access key ID and the secret access key ID. Let me show you the steps again. I go back to the AWS Management Console. I go to Identity and Access Management under Security and Identity. I click on delete your root access keys, manage security credentials. I go to access keys and the secret access key ID, click on the plus sign, and click on create new access key. And then just click on show access key. Now this is the one that I will use to authenticate. I copy the access key ID, go to the terminal, and paste it. Enter. Now this asks me the secret access key ID. I copy this one, I paste it, enter. Why I use this access key, secret access key ID is to authenticate this terminal. Now it's asking me the default region name, which means in which region I want to log in and access my resources. I just type in US West 1. That is for the Northern California. Enter. Default output format, by default it will be JSON, JavaScript object notation. Enter. This configures my CLI now. Now I'm good to go, and I can just go ahead and do anything, spin up the instances, remove the instances, load balancer, Elastic IPs, anything I can do. I think it's clear so far how to configure the CLI. Right. Now let's do one thing. We'll just go ahead and create an instance, a launch instance using the CLI tool. Now the process of creating an instance on the CLI is a bit different as compared to doing the same operations on the AWS Management Console. On the AWS Management Console, you can assign the security group and the key pair while launching the instance. However, this is not the case on the CLI. You have to create security groups and the key pair first and then launch the instance. So the security group and the key pair, they should be created before you can just go ahead and launch the instance. So during launching the instance, you have to assign the security group and a key pair that you have just created beforehand. So you have to create the security group, then the key pair, and then you have to launch the instance. All right. So now, as a first step, I will show you how to create a security group. Now, over here, the command goes as AWS space EC2 space create. Security group, AWS space EC2 space create security group space group name, which means what's the name I want to assign to the security group. I'll name it as web server dash SG. That stands for security group. Right. AWS space EC2 space create security group space group name, that is web server SG. Now I have to assign the description. Description, then space apostrophe. Now if you can recall, we assign a description to the security group. This security group is for our web server. Enter. So this creates my security group with a security group ID SGF1780695. If it is copy the security group, let me just do that. And let's go back to the AWS Management Console. I think it should show over there. You can see this is the one. This one. It is not reflecting on my management console. Now, the security group has been created, but I want to see what are the inbound and the outbound rules it has right now. So the command goes as AWS space EC2 space describe security groups, group name, web server dash S3. Now this shows me the inbound or the outbound rules in the JSON format, JavaScript object notation. If you can see egress, see the thing is, if I'm saying egress, EGREWS, which means, I'm sorry, egress means this is the outbound rules I'm looking into right now. Outbound. For the inbound rules, I will say it as ingress. Right. Now, as of now, it is showing me the permissions in egress, which means the outbound rules. It says IP protocol -1, IP ranges CIDR IP 0.0.0.0.0/0. What does this mean? This means that I'm allowing all the traffic during the outbound rules, within the outbound rules. If I just go back and see over here, you can see it is allowing all the traffic to all the sources, to all the ports, to all the destinations. This is represented in this way. IP protocol -1, CIDR IP, all the destinations. Also, you can see there's no inbound rules. Why? Because it should show the inbound rules in the form of ingress somehow. But if I just go back and see there's no inbound rule. So now I have to start defining the inbound rules for this security group. Okay. So now I will run the command as, let me just hit clear. AWS space EC2 space authorize security group ingress, which means I want to add the ingress on inbound rules for my security group. Space, I have to define the group name. For which security group I will define the inbound rules. Web server dash S3. Now it's time for me to define the ports, protocols, and the CIDR range. Okay, so I will allow protocol TCP port 22 CIDR 0.0.0.0/0, which means I want to allow the inbound rules TCP port 22, which means SSH from all the destinations, I'm sorry, all the sources. Enter. It's created. If I just go back to the management console, to the web page, refresh it, you can see it will show up over here. Let me define more rules. I hit the upper arrow key and I'll just define port 80. Enter. Port 80 is for the HTTP traffic. Port 443. Enter. If I just go back, refresh the page, you can see the rules are showing up over here. If I want to see the same thing in the JSON format over here, I'll run the command AWS space EC2 space describe. Sorry. Groups. Group name. Web server -sj. So now I can see all these rules in the JSON format. 422, 80, and 443. Right? All right. Now it's time for me. So this creates my security group. It's time for me to create a key pair now. So the command goes as AWS space EC2 space create key pair key name web server -kp. So the command goes as AWS space EC2 space create key pair. This is the key name web server -kp. Now I want a copy of the private key to be saved on my desktop because I will use this private key to SSH into my Linux instance. So I'll run a query space apostrophe key material. Apostrophe closed space hyphen output in the form of text because I want the output in the form of text format space a greater than sign space. Now I have to type in the name of the key file that I want to be saved on my desktop. Web server -kp.pm. Enter. Let's take its time. Looks like it's frozen, something like that. Just give me the output. Wanted for the command line help, just type in AWS space help. Yeah, AWS space help. Okay, so this created my key pair. If I go to my downloads right now, I'm not sure that's created or not because it took too much of time. Hang on one second. Web server. Okay, so this has downloaded this PM file. You can see the time today, 10:39 p.m. to my desktop right now. Let me just drag and drop it on my desktop. All right. So this saves my .pm file. This one. All right. So two things have been created. One is my security group, and the second one is the key file that is just managed to download that on my desktop. Now it's time for me to launch the instance. I will use both these security groups and the key pair to successfully launch my instance. How will go about doing that? First thing first, I will have an AMI ID handy. Now you will have your own custom built AMI, and you will have the AMI ID of that. So just for this example, I'm just taking one of the AMI IDs, this one. Let's copy this one, right? And I paste that notepad file. So now I will run the command AWS space EC2 space run instances. Now I will start defining my inputs. First thing first, I have to define the image ID. That is the AMI of the instance that I'm going to launch. This is the one. Then the count of the instances. One instance I want to launch. Space instance type. T2.micro. Then I have to define the security group. Web server -kp, I'm sorry, -sg, then the key name, web server -kp. So these security groups are the key files we have just created beforehand. So the command goes as AWS space EC2 space run instances, image ID, the AMI, the count of instances, instance type T2.micro, and these are we already defined now. Enter. So this will launch my instance, and I can see the description of the output in the JSON format. You can see over here. This launches my instance. If I just go back to my instance dashboard, you can see this instance is getting launched now. This launches my instance. Right. Now, I need to wait for a few seconds because if I just see, I can see the public IP of this instance I can see the private IP of this instance, not the public IP. So I would like to see the public IP of this instance because it takes a few seconds for the public IP to be associated to the instance. Okay. Ramakrishna is saying you're unable to copy the command we used today. I'm not sure you're not able to copy because I'm able to copy Ramakrishna. I'm not sure why. So now I need to see the public IP of this instance. So what I will do is I'll just go to the JSON format, this output, copy its instance ID, and run the following command: AWS space EC2 space describe instances, instance ID, and it will just give me the format, this output in the JSON format, and I can see this is the public IP I got. So I have the public IP, I have the key file downloaded on my desktop. I can very well use both these two components and attributes to sign in to my Linux machine. All right. This is how you can use your CLI to launch your instance. Right? Just an overview. Any questions, any doubts so far? Ramakrishnan, can you send a copy of commands? Okay, yeah. Of course, Ramakrishna, I'll share with you on the slide. If I'm not sure that I have that on the list or not. Give me 1 second. Yeah, I will share with you, Ramakrishna, with all of you the commands that I've used today. Right. Yes, Shiva. After this, of course, we'll use the steps to connect to the instance using putty.pbk and PEM file. So we already know that how to connect to the instance. Okay. Yeah, you're right. So after that, we'll follow the same steps, putty, and we'll convert the PM file.ppk and just connect to the instance. You're right. Yes, Subhajit, you need to practice. This is not a rocket science. It is that you have to run the commands once or twice or thrice, then you're good to go. Nothing much. Okay. Shiva is saying how to change public IP to Elastic. Shiva, I have to assign a new Elastic IP to this one. Right. I'll not go further because that's it. I don't want to go deep into the CLI because this is not mandatory and you never get even a single question in the certification from the CLI. So I'll not go further right now. Of course, Kamesh, we'll discuss the AMI creation once we discuss the EBS. Once we discuss the Elastic Block Store, then we'll discuss the AMI creation. Okay. Shiva was saying we can do whatever we can do in GUI. Yes, Shiva, but this is a second option. Some people are comfortable using CLI. That's why I showed you the option. Okay. So guys, any more questions regarding the steps that we have done so far? No, Kamesh, is not important from the certification perspective because not even a single question comes in from the certification. But I just want to give an FYI because you may use the CLI in the real-time scenario. Okay. All right. So this completes our third topic, the CLI for today. Next, we'll discuss another topic that is a load balancer. Now, till now, we were discussing the manual processor like Elastic IPs or network interfaces. Now we'll discuss another topic called load balancers. Once you go to the EC2 dashboard, you can see that on the left side. This is the automated process to launch your instances automatically or perform the failover. Ramakrishna, if you want to reach me, you can reach support@adrega.co and they will get back to me. Okay, you can open a support ticket and they will get in touch with me. So let's discuss our load balancer. I'm not sure we can't cover the entire thing today itself, but at least I'll cover the theory. Okay. All right. So let's discuss the ELB. That stands for Elastic Load Balancer, the basic concepts. What's an ELB? An ELB automatically redistributes the incoming traffic for its set of EC2 instances. It load balances the incoming traffic between your instances, and these instances can be either collected together in a single availability zone, or they can be spanned across multiple AZs. Right? So the thing is, when in your huge architecture, which is spread across multiple AZs, you will never ever route the user's traffic towards your instances. You will have a load balancer sitting in the middle. So what it will do is you will route the user's traffic towards the load balancer. So this will go in such a way that, let's suppose this is a user on the top. He will send the traffic to your designated load balancer. This load balancer will further distribute the traffic to the set of instances running in different availability zones. Right? So if I'm saying it automatically redistributes the incoming traffic, and also it load balances the traffic, which means it ensures that all the instances and all the availability zones receive the equal amount of traffic. Okay, so in an ideal situation, you will have the user send the traffic to the domain name associated with the load balancer, and the load balancer will perform the rerouting of the traffic at the backend. Apart from that, the purpose of the load balancer is that it performs a health check of your instance. Let's suppose this instance on the right side is unhealthy. Unhealthy means that might be it is stopped, might be it is terminated, might be it's in frozen state, whatever reason can be. If an instance is unhealthy and it is not in a situation to handle users' traffic, the load balancer will perform the health check. If this instance, because it is unhealthy, fails the health check, the load balancer will stop sending the traffic to it. Why? Because if the user over here sends the traffic to the load balancer, and the load balancer by mistake sends the traffic to the unhealthy instance, the user will get the page can be displayed. So to avoid this kind of situation, whenever the load balancer gets to know that within the architecture an instance is unhealthy, it is not fit to handle users' traffic, it will stop sending the traffic to it. Right? Now, this doesn't mean that the responsibility of the load balancer is over now. The load balancer will keep on pinging the instance. Once the instance comes back up, once it is healthy, the load balancer will start sending the traffic to it. Okay? So the elastic load balancer always ensures that your instances are up and running, they're in good shape, they're healthy, and it performs the health check of your instances. You can assume that your load balancer is a traffic manager. It's a kind of a traffic police or traffic cop. It always ensures that none of the traffic or none of the roads nearby is not being jammed by the traffic. In the same way, the elastic load balancer facilitates that or ensures that all the networking routes are being smooth. It distributes and manages the entire web traffic efficiently. It ensures that none of a single instance is overloaded, and the traffic is distributed evenly across all EC2 instances. Right? So the load balancer always ensures that there's a smooth flow of the traffic across your architecture, and all the instances receive the equal share of the web traffic. All right. So we have discussed the thing that the load balancer always facilitates the continuous health monitoring. It keeps on sending the ping messages, the keep alive messages to get to know that the instance is up and running. Now, this is quite important. An elastic load balancer always helps you to build a fault-tolerant design. If I'm saying fault-tolerant design, what do you mean by that? In this example, let's suppose that this is the load balancer ELB, and it is sending the traffic to all these instances running in the same region of Northern California. One thing you have to keep in mind, the load balancer works in the premises of a region upon different availability zones. Within the region of Northern California, you have 3 different availability zones: US West 1A, 1B, and 1C. All these availability zones, they have the equal share of traffic. Now, due to some reasons, this entire availability zone goes down, which means that all these instances will not be reachable. This load balancer, once it performs a health check, it gets to know that there's something wrong with all the instances in the same availability zone. Consequently, it will stop sending the traffic to it, and it will reroute the share of traffic to other healthy instances in different availability zones. So both these different AZs will receive equal of 50% of the traffic. Which means that your elastic load balancer provides a great level of fault tolerance and reroutes the traffic in case of an instance or an entire availability zone fails. It's completely automatic. If this kind of situation occurs where the instance or the entire data center goes down, the responsibility of the load balancer is to perform the failover automatically on your behalf. We'll discuss how to configure this thing, how to achieve this kind of fault tolerance, but the entire thing will be automatic. But yes, you have to keep one thing in mind. All the resources should be in the same region. They can be scattered across different AZs. Okay. Any questions so far? Kamesh, yes, it supports different regions. I'm not saying that it doesn't support different regions, but it cannot load balance the traffic across different regions. It supports different regions, but you can't load balance the traffic using a single load balancer. So you have to have independent load balancer in each region. Okay. Venkat, your question is how to clone instance into 2 by trying out load balancing. Is there a way to clone instance with all instances to multiple AZs? Venkat, regarding your question that whether we can clone instances with installation to multiple AZs, we can achieve that using the concept of auto scaling. We'll discuss that. Once we cover the load balancer, we'll discuss the auto scaling to see how we can create different clones of instances automatically. Okay. Any questions so far regarding the theory that we have discussed? No? Okay. No questions. Guys, let's take a 5-minute break. I need a 5-minute breather. Once we come back, because we'll have another 25 minutes left to discuss the load balancer. Let's take a 5-minute break and we'll just continue with the load balancer because it's a very, very lengthy topic. we have to discuss tomorrow as well. Okay. So let's take a break for 5 minutes. Just a 5-minute break. Just refresh yourself and be back in this right 5 minutes. All right. Thank you. Welcome back. All right, with sort of a 5-minute breather, we can just continue now. We have a question. Venkat is saying you mean to say ENI and ELB will not work across two geographical regions? What if the entire region is down? Could I make the request go to ELB in another region? Venkat, whether it's an ENI, whether it's Elastic IP, or it's a load balancer, they can never surpass a region, right? Just in case if you have to load balance the traffic across different regions, there's a service that we'll discuss later on that's called Route 53. Again, it's called Route 53. We'll discuss that. This helps you to achieve a failover upon different regions. Okay? Let's move further now. Now, the load balancer supports 4 types of traffic: HTTP, HTTPS, TCP, and SSL. So these are the 4 different kinds of traffic it supports. Regarding the pricing, it is dependent upon pay-as-you-go model. Okay, so it is an hourly-based charges. You pay for the time duration, and you pay for each gigabyte of data that surpasses the load balancer. Because what happens is that, for example, let's suppose if this is a user, he's sending the traffic to the load balancer. The load balancer will send the traffic towards different instances. The user's request or the data that surpasses to the load balancer and reaches the instance, that traffic or the request is being calculated by each gigabyte basis, and you have to pay for each gigabyte of data that surpasses through the load balancer. All right. Now, there are 2 types of load balancers that is being supported. The first one is the internet-facing or the public load balancer, and the second one is internal. So the internet-facing load balancers are exposed to the internet, whereas the internal load balancers are not exposed to the internet and are purely intended for carrying out the internal operations inside of VPC. So the internet-facing will receive the traffic from the internet, whereas the internal one, they will just carry out your internal operations. That's it. All right. So this is a brief overview of the, I would say, the load balancer. Tomorrow we'll discuss our practical session of it, how to create our load balancer from scratch. Now, there's a very important concept that I'm going to discuss, and this is quite important from the examination perspective. It's called ELB, connection training. I will show you how to configure that. By default, it is linked to 3. It is about 10 seconds. It is equal to 5 minutes. ELB connection during time is a time frame during which your load balancer will keep on routing the traffic or keep a hold of the traffic. Now I will explain you what do you mean by that. Let's suppose that this is a user. I'll discuss the practical application of all these things tomorrow. This is a user, and he's sending the traffic towards the load balancer. Guys, please pay attention. These are very important concepts from the examination perspective. I will not repeat these concepts tomorrow again. Okay? So please don't ask tomorrow that what this thing is, because I'm explaining this thing in detail right now, and these are very important from the examination perspective. Now the user is sending the traffic to the load balancer, and the load balancer is sending the traffic, let's suppose, these two instances, instance 1 and instance 2. Now, in an ideal situation, what happens is that the user sends the traffic to the load balancer, and the load balancer routes the traffic equally to two different instances. Now, something went wrong, and the load balancer lost the connection towards both these instances, or both these instances went down, or they go down. What happens? In that very case, if the user sends the traffic to the load balancer again, the load balancer is clueless. There's a big question mark, because the load balancer doesn't know what's going on, because right now none of these instances are registered to the load balancer. Consequently, what we'll do is, this session that the user has already sent, it will hold the user session for next 300 seconds. That's called the connection training. In the 300 seconds, which is equal to 5 minutes, it will keep on hunting for the instance. It will say, instance 1, are you up? Instance 2, are you up? Instance 1, you're up. It will keep on pinging, and it will try to level best to get hold of any one of these two instances. Within 5 minutes, let's suppose this instance 2 comes back up. Instead to say, okay, load balancer, I'm up. Could you please forward the user request to me? Load balancer will say, okay, I'm sending the user request to you. Within 5 minutes, if any one of the instances come back up, the load balancer will forward the user's traffic to that instance. But within 5 minutes, or once the 5 minutes gets completed, and any one of these instances do not show up for the load balancer, the load balancer will say, hey user, I'm sorry, the page cannot be displayed. This is called the connection training. It's called the connection training. By default, it's for 300 seconds or 5 minutes. You can increase or decrease its value. Again, I repeat, connection training means that if all the instances reporting to the load balancer, they get deregistered or they go down somehow, and the load balancer is not able to reach any one of the instances, the load balancer will hold the current user session for next 5 minutes, and within 5 minutes it will hunt for any one of the instances that comes back up. If any one of the instances comes back up within 5 minutes, it will route the traffic to it, or else post the 5 minutes it will go back to the user saying that the request cannot be fulfilled. That's called the connection training. Tomorrow, once we discuss the practical application of this ELB, I will show you this option, but I'm not explaining you. Any questions, you can just ask me right now. Subhajit, there's no minimum time. You can just keep that to 0 seconds as well. By default, it's 300 seconds. You can keep it. You can just take it to 0. All depends upon how you want to configure your application. Raj is saying how many in the ELB, how many instances we can have. Raj, I would say depending upon how you structured your architecture, but I think from my perspective, what my experience says that a load balancer shouldn't handle more than 20 instances at one point of time to get the best performance out of it. Kamesh is saying if it doesn't goes to any one of the instances, then it will be charged. Kamesh, if we're not discussing about it charging over here, right? So it's quite the thing is that, of course, that if it's not passing the user's traffic, if it's not passing the user traffic to the instance, then the amount of data will not be calculated. So it's quite obvious that it will not charge you. Venkat, your question is, will it charge you? Would you be charged if you use the ELB one sample? Venkat, you can run one ELB free for the entire 1 year. You can use that. Okay. So this is about the connection training. The next concept is called stickiness. Now this is a very important concept from the examination perspective. I will show you how it's configured tomorrow, but I'm not explaining the concept because I'm explaining the concept right now today. Stickiness means that what happens is I'm explaining the default behavior. Let's suppose that this is a user. He's sending the traffic to the load balancer, and the load balancer is sending the traffic to the instances. When the user sends the traffic the first time, the load balancer will send the traffic, let's suppose, to this instance, second time to this instance, third time to this instance, fourth on this instance, and consequently, the consecutive streams would be aligned to the next instance. Next stream to this instance, another stream to this instance. So this is how it distributes the traffic. Now, if we enable stickiness, let's suppose by default the stickiness is enabled for 300 seconds. Which is equal to 5 minutes. What happens if you enable the stickiness? This will surpass the default behavior of the load balancer. What it will do is that, let's suppose that this is the user. He is sending the traffic to the load balancer, and these are the two instances. Let's suppose that you enable the stickiness for your load balancer for 5 minutes. What happens is that for next 5 minutes, when this user sends the traffic and it lands to the second instance first, for next 5 minutes, the user session will be established to the second instance only. Even if he refreshes the page multiple times, access the website again and again and again and again, within 5 minutes, his request will always land to the second instance. Because we're sticking his session, it's called stickiness. We are sticking his session to one single instance. Once this stickiness of 5 minutes this period gets over, then the load balancer will come to its default behavior and it will equally distribute the traffic every time the user accesses your website or refresh the page. You might have seen this thing. Whenever you pay any credit card or debit card bill, it says don't refresh the page, because the payment gateway, it does not want you that if you refresh the page, you may land it to some different website or web server or web page. It's the same thing. In the stickiness, it is always ensured that the user session is established or sticked to one single instance, while overriding the default behavior of the load balancer. Because the load balancer will distribute each consecutive stream to individual instances. That's called the stickiness. Right. So any questions regarding the stickiness and the connection training that I've explained to you? Very important from the examination perspective. Question comes up, that's what I'm stressing upon. No questions? Yes, Venkat, what's your question? So Raj is saying this is the session will stay for 5 minutes on the instance. You can see that, yes, Raj. Kamish is saying it will stick where the first request gets started. Yes, Kamesh, whichever instance the user gets first, his session will stick to that instance for the next 5 minutes. Whether the first instance or second instance, it can be any one. Whichever instance the user session is routed first, that session is ticked for next 5 minutes towards that instance. Venkat is saying how to manage DB load balancing in this case. Venkat, the multi-AZ does not work on the databases. It is purely for the web instances. For the databases, we have to incorporate a different strategy called multi-AZ that we'll discuss later on. Yeah, it's called stickiness or sticky sessions. Ramakrishna, yes, we can increase or decrease the value of stickiness. It all depends upon our application's requirement. Venkat, your questions, will both instances have the same RDS or different RDS? Venkat, I will appreciate if you don't discuss the RDS right now. RDS is a database option. Right now, I'm purely focusing on the web server. So RDS has nothing to do with this thing right now. Subhajit, you're saying that maybe discuss afterwards, but is it possible to configure stickiness for a specific application? Of course, Subhajit. You can also create the application-based sticky sessions. We can do that. Venkat is saying how is the user maintained between two instances? Venkat, using the connection training that I discussed. A user session is maintained between two instances using the concept of connection training. The connection training always holds the session and always ensures that any one of the instances caters to the user's requirement. Okay. So guys, this completes our topics for today. Any questions, any doubts so far? Anything that you want to add? Today's slides, I'm just dragging and drop the ink on the shared Google Drive so that you can access the same. Hang on one second, please. Okay. And also, I'm just giving you the list of the commands that I discussed today. Hang on one second, please. Okay, so this is the CLI, the command interface. So these are the commands that I used. So I'll save that on the Google Drive as well right now. So let me open this Google Drive. So I'm just uploading all these files on the Google Drive right now so that you can access the same. All right. Yes, Cesar, you have to use the same link. So the link will be the same. Still, if you want, I have just copy and paste the link so that you can just see that there's no difference in the link. So the link should be the same. The link should be the same. I'm copying and pasting the link for you again for your reference. Hang on one second, please. Give you 1 second. So just copy and paste the link again on the chat window so you can access it. All right. Azhar is, so I've given you the link. Azhar, Khurram is saying, will you use the website as per your last assignment? Because I have still some issue with the website and it's not up. Khurram, those are the assignments. Okay. So you have to follow the steps to see that the website is up and running. Okay. I'm not sure the steps because those are just the assignments. Okay. If you have any issues, you can just see the documentation again, see the steps that ensure that you're following the right steps to host a static website on the EC2. Kamesh, the assignment for today is that you have to run the CLI commands. So I've copied and pasted the CLI window on the Google Slides. Please practice the CLI. That's the assignment for today. That's why I've copied and pasted the PPT slide. The load balancer assignment I will give it tomorrow because we haven't discussed the load balancer. We have just discussed the theory of it. Tomorrow I'll just go in depth and discuss the practical side of it. Tomorrow I'll give you more assignments for the load balancer and the auto scaling. For today, you have to just discuss or just practice the CLI. That's it. Okay. Any more questions, guys, before we just wind up? And guys, please, it's my humble request. Please fill in the feedback form once the session gets over, because only few people just fill in the feedback form. So once the session gets over, you have to spend your few seconds and rate the instructor, the content. Optionally, you can also put your comments. Okay, so please fill in the feedback form. Anything before I get wind up? Any questions, any doubts? Ramakrishna saying, can you check with this? I'm unable to see it on the location. Guys, are you able to see the slides and the content that through the link that I just gave to you? Because Ramakrishna is unable to see the same. Kamesh is saying yes. Guys, can other people confirm? Yes, so it is saying so. Ramakrishna, other people are able to access it. So I'm not sure why I'm not able to see the content. Other people are confirming that they're able to access it. Yes, Venkat, there are 4 slides. There should be 4 slides. Yeah, you're right. Yeah, Ramakrishna, you have to check because all people are responding that they're able to access. Okay. So that's it, guys. Thank you so much for your time and patience. We'll meet tomorrow. We'll just continue with our load balancer. Last but not the least, please fill the feedback form. All right, goodbye. See you tomorrow.